Okay. So a surface integral of some f of x, y, z across where z is just a function of x and y. Okay. So this is the formula. And so what we're going to try to do is evaluate this integral upon a surface where that surface oh, that's a 6. Okay. So we have a plane that is existing within the first quadrant. Okay. So the first thing to ask ourselves is to use this formula, we need a g of xy. So z is a function of y. So my g of xy will equal 6 minus 2x minus 3y. Okay, so that's just isolating c. All right. And so I got to follow this formula. And so what is g sub x would equal -2. And g sub y would equal -3. All right. Now we have to do a double integral over the domain that is within the xy plane. Okay. So the first thing to do is to try to imagine, what am I even dealing with here? Okay, so I'm imagining this plane existing within the first quadrant. So it out and figure out what our domain actually looks like. So if I set x and y equal to 0, I get z, which equals 6. So I'm going to go 2, 3, 4, 5, and 6. Okay. Now, if I set y and z equal to 0, I'm going to get, well, 2x divided by 2x, which equals 6. And so that'd be 2 divided by 6, which is 3. That'd be 1, 2, and 3. Just label this as 6. We'll call this guy 3. And then if I set x and z equal to 0, well, you get 3y, which equals 6. So 6 divided by 3 is 2. Okay, so that's the plane that I'm dealing with at this point. Right? But this says we're just going to integrate upon the region which is with respect to x and y. So we're not going to integrate in the z direction. So when we do triple integrals, you integrate with respect to the three-dimensional volume first. So we would integrate with respect to plane. But z is a function of x and y. So we're just going to integrate with respect to x and with respect to y. So let's redraw this and consider what domain we're actually dealing with. So if this is x, this is y, this is z, okay? If I project onto the xy plane, this is actually the line I'm going to be dealing with. Okay, so this is just the projection of the plane onto this three-dimensional plane in space onto the two-dimensional plane, which is just the xy plane. Okay, and so the projection of this is, well, what do we? How would we define this line? Y would equal negative 2/3 x plus 2. Okay. So remember, you have to pick which direction that you're going to integrate. And while it's easier to find it as just y, which equals negative 2/3 x plus 3. And so I'm going to integrate in the y direction first. Okay. So I'm going to go in this direction first. Okay. So my dy is going to be defined as y, which equals 0. And then I'm going to go to y, which equals negative 2/3 x plus 2. So I'm just going from the bottom of that line, from the x-axis where y which equals 0 up to the line y which equals negative 2/3 x plus 2. And so then I have to consider, well, what is my dx direction? Now this switches to being a one-dimensional quantity. And so this guy is just going to go from 0 to 3. So dx will be defined as x which equals 0 to x which equals 3. So setting up my integral. So where is my integral? Well, it's already up there. Okay, so we are going to have the integral. Well, the outer one, I said I'm going to do dx on the out one, so that's 0 to 3. It's negative 2/3 x plus 2. And this is going to be x, and then multiplied by the square root. So g sub x squared, where's my g sub x? That's negative 2. So that would be negative 2 squared plus negative 3 squared plus 1. Okay. And the first part of the integral we decided to do with y, and the second part of the integral we decided to do dx. Okay. Now, if we square negative 2, that's going to be a 4. Squaring negative 3 is going to be a 9. So 9 plus 1 is 10, and then 10 plus 4 is 14. So that becomes the integral from 0 to 3. And I'm just kind of simplifying things at this point. So it's negative 2 divided by 3x plus 2 times x times the square root of 14 dy dx. Okay. Now we're integrating x times the square root of 14 with respect to y. We don't have any y's in this problem, so remember we're treating the x's as a constant. So that's going to equal the integral from 0 to 3 of yx root 14 evaluated at 0 and negative 2 divided by 3 times x plus 2. And an integral with respect to x. Okay, we don't care about the 0 part. So this is going to equal the integral from 0 to 3 of negative 2 divided by 3x plus 2, and then multiplied by x times the square root of 14, and we're going to integrate with respect to x. You know, just to make things easier, I'm just going to pull that square root of 14 to the outside. And so all I'm doing is pointing the square root of 14 to the outside and distributing the x onto the inside. Okay, and at this point of the problem, it's just integrating a polynomial. So that becomes the square root of 14. Let's just make a big parentheses right there. And so that'll be negative 2x cubed divided by 9 plus x squared, and then evaluated at 0 and at 3. So that's going to be the square root of 14. Okay, so if I consider negative 2x cubed divided by 9. All right, so what's x cubed? X cubed is 27. So 27 divided by 9 is just 3. So that would be negative 6. And then 3 squared is, oh, 3 times 3 is just 9. And so the answer ends up becoming the square root of 14 multiplied by 3. And so that's surface integrals with just respect to x and y. Z is being a function of x and y.